Hmm. Hello all, welcome back to my YouTube channel all about VLSI. In our previous sessions of decoder-based RAM verification, we were developing write monitor and we have seen the write driver, read driver, generator and environment and test we need to discuss in our upcoming sessions, and we have also seen about the type of coverages, like what do you mean by bins and how you're going to check for the bins and all this and all things we have seen in our previous sessions. Now let's start with another file development, which is basically our read monitor. So basically, write monitor was monitoring the signals which write driver was driving from the interface, and it was storing it in a transaction, and it is going to send it to my scoreboard and reference model. Same thing, read monitor, it is going to monitor the transactions which my read driver is driving, like read enable signal and read address. It is going to monitor, and it is going to monitor them from the interface, and it is going to store it into the transaction, and it is going to send it to the scoreboard and reference model. Okay, yes, so let us try to develop the read monitor file, which is going to have, yeah, this is the file which we were developing previously. This is write monitor and all. Now let's develop the read monitor file. So let me include my class ram underscore read underscore monitor, which is my class name. And let me declare the virtual interface handle virtual ram underscore if dot read underscore monitor is a mod port name, followed by VAF is a handle name which I'm going to have. Now I'm going to declare the mailbox handles, mailbox hash transaction. One mailbox handle is to send the data to my scoreboard. So scoreboard underscore read underscore mailbox is one of the mailbox handle which I'm going to have. And mailbox, this is hash. So mailbox hash transaction scoreboard underscore write underscore mailbox. That is for write monitor. Okay. And these are the mailbox handles I'm going to have, and one more variable just for tracking the count of whatever the transactions which we were having, and the new function for basically getting the interface and mailbox instances from my environment. So virtual ram underscore if dot read underscore monitor VIF, and another argument over here is mailbox transaction scoreboard read mailbox is one of the other transaction which I'm going to have, and also mailbox transaction scoreboard underscore write underscore mailbox. So these are the mailbox arguments. I mean new function arguments which I have declared over here. And let me copy it. This dot VAF is equal to VAF, and this dot read underscore scoreboard underscore read underscore mailbox. That is my scoreboard mailbox instance. I'm going to copy it to the local one, and write underscore mailbox, which is equal to scoreboard write underscore mailbox. So this dot, that's it, and followed by end function. Now what I'm going to do, I'm going to have my run task. So in this particular run task, I'm going to declare. So this particular run task, first of all, I'm going to declare the transaction handle. So let me first of all check out what is the transaction handle which has been declared over here. So which is simply transaction. So transaction TXN is a transaction class handle, and within a forever begin block, I'm going to first of all get that. I'm going to wait for the passage of VF dot read underscore VF dot clock. So I'm going to wait for the clock to be triggered. If clock has been triggered over here, then I'm going to wait for some time, because I need some time to data and valid commands to be generated by my I mean the design, right? So then after I'm going to monitor them data, which is equal to VAF dot data. So basically read data is given by your design, okay, and TXN dot valid is equal to VAF dot valid. So these two instances or these two properties are given by your design. Design is going to give us our data and valid that my read monitor is monitoring whatever the design content which I'm going to get, that my read monitor is going to monitor. And I'm also going to check one condition that if my valid, if it is equal to 0, that means valid has not been generated yet. Okay. So what do you mean by valid and the significance of valid? We have discussed in the design of decoder-based RAM. If you haven't watched that, I recommend you to rewatch it. So dollar display valid not generated, waiting for valid. So valid has not been generated. I'm waiting for valid signal. I'm just printing it and following enter. Now, if valid has been generated, then I'm going to increment my observed underscore count variable, observed underscore count plus plus, and I'm going to call the print method which is present inside my transaction, and I'm going to pass the read monitor as one of its alternate. I'm going to pass it. And after having this particular things done, I'm going to put the transaction which I've got, put the transaction which I've got, which from the interface to the scoreboard mailbox handle. So dot put of txn and scoreboard underscore and also reference model underscore the mailbox dot put of txn. So whatever the transaction which I've collected from the interface, I'm putting it into the my mailbox and for when and end task and end class. That's it. So this is a simple read monitor which we have developed, and this particular read monitor is basically monitoring whatever the data contents which we have, which the design is giving to us, right? Yeah, and also we have forgotten to add the read enable signal which is present in the interface. Txn.read enable is equal to wave.read enable. That is whatever the read driver is driving, that we are collecting into my read monitor. That's it. And in our next session, let's try to develop our reference model and scoreboard and let us integrate them in my environment. Okay. Yes. So that's about this particular session. Thank you.